Okay, this is an optional introductory video for the Module 4 topic. It's going to seem like we're doing some of the same old things, but I wanted to kind of give some motivation. It's also in the notes if you read that we've spent some time learning the technique, and now we need to get to our actual sort of overarching learning objective, which is modeling. It's about taking problems and putting those into a framework. And so if you just think about what we're doing in Module 4 and the idea of sort of our modeling, right, just the general topic being our category, the readings, the first reading you have is from Monahan, and it's a long reading. Actually, it looks longer than it is. It's like 75 pages, but really a lot of them are just problems, so you don't have to read those. They're just there as part of the scan. But it has just this menu of different problems, and you read it, and you read the setup, and ideally you think about how would I put that in some of these structures or these constraint and objectives kind of problems that we've been doing, and then you see the algebra that they present. Typically the example will show an algebraic representation, and then it has a figure with a spreadsheet that would solve that model. And so that's a great sort of reading to kind of give you the breadth, right? So you're just seeing example after example. The other reading we have goes with our nutrition, our sort of semester project topic. And it's Wild Chapter 10. It's from a food policy book, actually. And the topic of nutrition comes in there in a couple of ways. And one of the ways is through nutrition or low-income assistance in nutrition. And so Chapter 10, I believe, is on food insecurity, poverty, and some other things. And so the first 10 or 11 pages of that chapter kind of discuss the problem, discuss sort of the government role, USDA, and then you get to the end of it and you see they have this model that they use to sort of set government procurement or government policies on what to expect when you're providing nutrition assistance. And so it's a good reading. When you get to the end of sort of the thrifty food plan discussion, you can stop there. I put the whole chapter together, though. You can keep reading and learn a little bit more about some economics of poverty and nutrition and how they interact. But we're mostly interested in getting up to that discussion on modeling. The lectures and lab this time really do touch on this idea of being a modeler, going through the steps. The first lecture actually just takes something we've already talked about and says, how could you fix this? We've got a problem here. What if we have more data to fix it? And so you'll see that. It doesn't relate to linear programming directly. But when we get to lecture 2 to 4, you're going to start with a simple model. It just is a farm crop problem with profits. But we want to look at the solution, identify some margin or some piece in the results that gives us a new question that we have a reason to believe may not have been modeled in the correct detail. We may not be using all the information that we could, and that might be something. It's always appropriate to say, how would I describe the analysis? How would I interpret what I've got here as results? And if it feels difficult, or if you're saying a better model, a remaining question, those kind of things, if they exist, if those statements are working their way into your discussion, then you have to ask yourself, how easy is it to get this additional data? Should I change from the basic model that Keeney gave me here and try to improve on that? And that's exactly what the design here is. So it's built so you can revisit the data. I've given you the budget data that supports the first model, and it'll support all the other ones you have to do. So you have to go back and see, could you make an improvement? And so the idea is to rebuild or modify the model, solve it, and then return again to this analysis step. First thing we'll do with that farm model that starts lecture 2 is add in a labor component. That'll be lecture 2 and 3. There are a few things we can do there. Second thing would be to add in some sequence or timing issues in agricultural production, and they that's a general issue, right? Um, we've been doing lots of sort of production planning without noticing or without paying detailed attention to the idea that some things have to come before the second stage, and the second stage may have to come before the third stage. And in the lecture, I'll talk about some dynamics and how this might not be considered fully dynamic, but the sequence could be important. And then, of course, when we get to the lab, your question is going to be, do labor and sequencing interact in an important way? And we wouldn't do a lab if they didn't. So I'll just tell you, you're going to have to work on that and try to put together the labor component with the sequence component and see how that affects the analysis. Every textbook has something like this when you're talking about modeling. You may have some problem statements, you make the model, you do the calculations, and you're still on the analyst side, but it's when you get to this point, the interpretation, that you may feed yourself back, right? You may go back here, turn around. I'm not ready with this interpretation to hand it off to people who are going to make decisions and revisit the calculations. You may revisit the model, and that's what we're talking about here. So finding new information, rebuilding the model, right, and this sort of circular issue. Obviously, if you're going to follow these things and sit around and think about what does it take to move across this bridge from the analyst world to the real world, it never stops, but in a way it has to stop. And so that's why some people call it the art of modeling, right? There are even textbooks that refuse to, they or not refuse, but they intentionally put the art of spreadsheet modeling, the art of economic modeling in the textbook title, because the idea that you're ever going to get this perfection is wrong. And so we're always going to be making choices, and in that way there's no scientific sort of conclusion. There's no 95% confidence that says, okay, we're ready to pass our results off to the real world decision makers. And of course these could be the same people, but we're never really to sort of cross that divide. It's an art. When do you call it ready? And really it's an expertise that is developed in the problem area that lets you know when it's time to cross over, and some expertise in the the capabilities of the data and what we can do with the techniques we've decided to use. And really it's the reason you've spent so much time, you've spent a whole course basically working through research questions and a proposal type issue with Dr. Marshall, and of course you would continue doing that with your mentor. And so we want to that stuff doesn't go away. We don't put a plan together. It's not a baking recipe where we say, okay, I did the problem statement, it came directly from all this work I did. It's step, it's step, it's step. It can be revisited here. Yeah, and so let me just go through the items we have this week just as an overview. The reading from Monahan's a long chapter, many examples, and really, if you want to become good at this art, you need exposure. You need exposure to sort of the creative ways that people have used to set up interactions using just linear models. And some people call it tricks or tools of the trade. I don't like the word trick, but it's not a trick. It's trick in the correct connotation. A technique. A non-obvious mathematical interaction or something like that. For your capstone and LP, that's the mid-module deliverable. I'm asking you, take your topic, your capstone topic, find some component of it that might fit into an LP setting, and think about your expertise area and think about how that technique might add to it, and write something up, write a description up of how that can be used. Now, I'm not trying to force you to use a tool from this class for your capstone. I am forcing you to understand the idea of why do we use linear programming so much in these frameworks, in this course, and when we're talking about all these different types of problems. It's not because it's the best solution for every type of problem. In fact, it may be limiting in many cases. And one of the sort of topics we have left to do during your residency is How do you overcome those limits? How do you look at the next stage of modeling? But the value, the sort of the value of a teaching or a pedagogy around LP is that it forces you to name the objective, name this target. You know, if you had to choose one, what is the thing that the decision makers might key on? And then you're forced to address the limits, specifically, mathematically, quantitatively. What are those limits that exist that will always hold back that objective? And, by extension, define any trade-offs that exist. Now, there's certainly multiple metrics problems and balances that don't fit nicely into the LP framework. But if we've looked at a component of the problem and thought about it in that way, then we have a good decomposition. We have a good sort of piece of the puzzle about the broader analysis we might think about. In the lecture items that I actually spend time talking about through in terms of LP technique, they could be called tricks in this connotation. How do you make this work mathematically when you want to add buying and selling as an alternative? We talked a lot about shadow prices in Module 3, and we said, what's the maximum rental rate? Well, let's give the option. Let's say we've got some of our own family labor on this farm. If we're not getting enough return, why aren't we offering it out? And what would it look like if we put that in as a choice in the model? We talk about what if you have buying and selling for the same thing and how that can be dangerous. You can generate some solutions that don't work the way you want. The other thing we do is transfer activities. So the idea that you make something in one activity, but really you're making it just to transfer it somewhere else inside the model and use again. The classic case is I'm a crop producer. I make some corn and I might want to feed it somewhere else. There's another activity waiting for that corn to be made, to grown and harvested, to be used as a feed input. And then, of course, balance constraints are sort of dovetailed with those transfer activities. If you're transferring things around in this business model or this business representation, mathematical representation, the ins and the outs, right? The stuff coming in and stuff going out have to balance out. There's a supply and demand internal to the firm that has to be accounted for. It's easy to make a mistake, and making a mistake there may not show up mathematically. It may not give you this. Solver may not just stop and say you can't do that. You'd be giving yourself something for free in that kind of model. The Monahan sort of typical example looks like this. There's an algebraic version and then a spreadsheet. If you want to build a spreadsheet, that's fine. I don't have all the examples. You'll see right at the beginning of the reading there's a note saying I've lost that zip file that had all these examples, but they're pretty easy to build, and you're certainly welcome to do it. If you need help with one, let me know. If it seems important to you. I'm trying to give a lot of exposure in this chapter for people who are going to have very different experiences going forward into the capstone project. The item 2 is the reading from Wild. We're working on nutrition models. You've just in Module 3 done your first sort of group combined model. And so let's see how somebody else is using a model, and that's the USDA Thrifty Food Plan. It's not linear programming per se, but it's very similar. They use nutrition constraints the same way we are. And of course, when you get to residency week, you'll be asked to deliver via presentation, some model that revolves around the nutrition problem. The reading's very policy focused. You don't have to be that focused on policy or sort of answering some big question. It's a ripe area though, the food pyramid and lobbying, and to get your representation there is an interesting topic. You know, if the USDA, if the federal government is going to be out there promoting foods, why aren't they promoting your food versus some other, if you're an industry group? Federal, state healthcare costs and how they might be able to bring those down via an investment in nutrition, education, regulations. It's a key public policy area. And you see things like taxes on soda and sugars. Another area is marketing, product development. What kind of qualities of a budget food item, right? This is what if, we're competing on sort of price, but what kind of nutritional claims can we make? Here's a broad overview for that TFP, that Thrifty Food Plan. You're going to see them talk through. It's a model that comes in with a target. It has a constraint on the cost. So they basically say this is the minimum cost. This is the target cost, $3.89 or whatever it is. let's make a model that fits that. And the way they're going to fit it is to minimize the difference from what people typically consume. So they have all this food survey data on what people consume, and they say, okay, we don't want to disrupt lives and too much, so what's the sort of minimum disruption from normal eating patterns that gets us these nutrition constraints, these target areas. And so it's a different notion in some ways. So when you read that, you might think about back to your regression topics, where your idea was to measure the error and minimize it. Right? If you recall, your regression problem was an optimization. It was minimize the sum of squared errors subject to the fact that you're saying the data that you have is true, there's no error in its measurement, and then second, the functional form, the linear interaction between the dependent and independent variables. Sorry for the offset here. This scan did not come out perfectly, and you're going to see that when you read the reading. But table 10.3 in Wild looks at cost items, and it says what happens if we get this target cost of $3.89, and then we look at our survey data and it's $5.34 is what people are eating. Well, the target is to get the cost down to $3.89 per day per person, and then this distance function says how much different, it's a measure of how different is the consumption pattern in the target range from what people are currently eating, the current average. So to do that, you have to measure this distance thing, which isn't something that's important to me other than the fact that you realize they're using a constrained problem and that this is the objective, to make it as small as possible. And you see that they get a very low distance measure when it's just the cost, the energy, and the nutrient constraints. When they add the official TFP, which includes all these MyPyramid settings, you have to get above 3 servings of milk, etc. The distance blows up. And so you might question, what are the MyPyramid justifications? How much is the lobbying versus the science going into those kind of things? Yeah, and then I want to close out here just talking about a couple of hints as we go through here. And so the first would be a minor tip, because one of the things we're going to do in this setup is you're going to get a starting model and you need to adjust it and make a new model. Now I have a lot of these examples already done for you, but I want to tell you how you might think about doing it. So when modifying a spreadsheet model, already had a solver initiated, a lot of the information's already there. You can try to preserve the formulas by adding a new activity or row somewhere in the middle of the ranges. And I'll tell you what I mean by that. You still need to check everything and make sure nothing's messed up, nothing changed before you just run it. But I get frustrated with this if I have to build on something, and the idea is to reduce frustration. So let's see what if I can show you this tip. Okay, so I have my spreadsheet open. This is what you have. This is the simple model version. This is the first thing you have. Now, if you were going to add labor to that, and of course I've already set that up for you as the next one, but I want to show you how I did that in a way that preserved the solution I have here, the solver setup and the formulas. So these left-hand sides are some products, and they range from B7 to D7. And then if we were to open solver, you see that the choice variables range from B3 to D3. Now, if you just add a column right here, go insert, the sum products here stay B7 to D7, and in solver the choice variables stay B3 to D3. I don't think it's going to let me undo that, but if I just delete that, but what I want to do now is I want to insert the column right here. Now I want to check my left hand side here. Now the sum product is spanning from B7 to E7. It knows the weak column belongs as the end of the range, and so I can put something here that's a new activity. Or if you look over here at the labor, you see I wanted to put the labor out here, so I have productive activities, then hiring labor there. Well, it's pretty simple to just copy and paste the wheat category there, and then blank this out and use it, and those formulas are all correct. And you'll see if you look at solver, it too is saying take B3 to E3. And so that works out nicely. You can add a bunch of activities over and over, As long as you add them interior to the ranges, then everything else will adjust. And that saves some trouble. The other helpful hint that we have is you're working through a lot. There's a lot of sheets here, and you get to the lab model, and it's going to ask you to build on this. It's going to ask you to take this lab model starting point and move in some of that hired labor information. And if you fail at that, or if you have trouble following through the lab handout, I want you to continue working on it and try to get help and ask a question. But if you can't, because you need the outcome from the lab model to start your assignment questions, I don't want anybody to get bottlenecked here, especially like sending an email into me or Alma or the TA. Sorry, if I use this again next year, it's just the TA because she probably won't be doing this again. I don't want you to get bottlenecked and not be able to go ahead and start working on the questions. And so there's something over here called emergency. And this is the emergency sheet. So this is what you need to start the assignment. Now I realize it's perfectly possible to just go ahead and skip the lab altogether. Well, I mean, you need the lab, but you could just move straight to this and try to work on this. But I'm asking you to do the honorable thing, try to work through the lab, try to make yours look this way. And of course, one of the ways you might be able to fix your problem is to look at the emergency or the solution spreadsheet here and try to get yours fixed. But this is what we're doing, right? The lab model is going to end looking like this and start looking like this, so you can see there's a few hang-ups that you may hit as you work through that. And I don't want those to get anybody off pace with the rest of their group trying to get ready and make their contributions with everyone else getting ready for that. So, but definitely ask your question. Be sure that you understand how to build that out. Okay, that's the helpful hint. The more helpful hint that closes this out. And so, with that, good luck with the rest of the module. And I'm very interested to see your work.